So now we would be studying C4.5 algorithm for building decision trees. C4.5 is a successor of ID3. The way we used to find out gain in ID3, similarly we would be finding out gain over here also, only we would be going one step ahead and finding the gain ratio, which would be the gain divided by the split entropy. Here we are using the same information theory concept for choosing the splitting attribute. The attribute which is having the highest gain ratio would be taken as a splitting attribute. So now we'll be taking the same example of the tennis play example, wherein we are having attributes outlook and temperature, humidity, wind, and tennis. The same example that we took in ID3. Here first we'll have to find out the global entropy of the table. Similarly, the way you had found out in ID3. So now you have to pick up any one of the attributes and start finding out the gain ratio. So let's now we are here. We have picked up the attribute temperature, and we have just listed out the values that temperature has got. There are rows which are having temperatures as hot, mild, and cold. Uh, how many rows are having positive values? How many rows are having temperature as hot and positive values are 2? Temperature is hot and negative value is 2. So now you got to find out the uh, information gain from each and every value of temperature. Similarly, the way we have found out in ID3. Then we have to find out the entropy of the attribute temperature. And so what have we really done over here? How do we get this 2 plus 2, 4 plus 2, 3 plus 1 is from here. Okay, and these values 1.9 and 8.81 is getting substituted out here. Okay, similarly, so now we have found out the entropy for temperature. Then you have to find out the gain for temperature. The way we have done it in ID3, here we are just putting the global entropy over here, which we found out in the previous slide, and we are subtracting it from the entropy of the attribute that you found out right now. So this is how we find out the gain for the attribute temperature. Now we don't have to stop over here. We have to go ahead and find out the split information or split entropy for temperature. And how do we go about it? What is this 4? What is this? These values are coming from here. 2 plus 2 is 4. 4 plus 2 is 6. 3 plus 1 is 4. So here what are we doing is we are taking into account the cardinality of each division also. So this is how we find out the split information, and we'll go ahead and find out the the gain ratio, which is equal to this would be coming as a numerator out here. So as we have done it with temperature, now you have to just go ahead and find the gain ratio for humidity, for wind, for other attributes that are there in the table, and you have to pick up that attribute as a splitting attribute whose gain ratio is the largest. So now, when we go ahead and find out the gain ratio for all the attributes that are there, we found out that Outlook has got the gain ratio, the largest gain ratio. So Outlook becomes the splitting attribute. What are the various values that Outlook can take? It can take sunny, overcast, and rain. So now what we do is we take the original table and divide up into the table sunny, table overcast, and table rain. So we are having table sunny, table overcast, and table rain. We have taken table sunny out here, and we got to find out the gain ratio for the attributes that table sunny has. So we'll find out the gain ratio of temperature, humidity, and wind, and whosever gain ratio would be more would be becoming the next splitting attribute. Now similarly we have to just move ahead and make the complete tree the way we have made it in ID3. C4.5 handles both continuous as well as discrete attributes. This algorithm actually happens to transform continuous attributes to nominal ones based on gain maximization, and thus it handles the continuous data also. Missing attribute values are simply not used in gain ratio and entropy calculations. C4.5 goes back through the tree once it has created it and attempts to remove the branches that do not contribute by replacing them with a leaf node. Therefore, it happens to generate more generalized trees and not fall into overfitting. Decision tree algorithm 4.5 improves ID3 in following ways: by dealing with missing data, by dealing with continuous data the way we have seen it in the previous slide. It happens to prune the tree by maybe replacing the subtree in case of error, and also replaces the subtree by its most used subtree. Here a subtree is raised from the current location to a node higher up in the tree. It happens to have a splitting approach wherein it is also using the gain ratio instead of gain. C4.5 is implemented as J48 in Weka. You can refer to the link given below to see an example of C4 4.5 with the continuous data. Thank you for your time.